So this is question 9 from the quick check. And on question 9, you had two options. So they were either linear and non-proportional or linear and proportional. So the question of linearity really didn't matter here, but I still want to talk about why they are versus why they are not. So this first one, we know that this is linear because this is just a plain x. There's no x squared or anything like that. So the linear part is good on that one. So we know it's linear. Now the proportional, remember, for it to be proportional, it has to be a straight line that goes through the origin. Well, it's linear. We have that part. It is a line. And then we know that this goes through the origin because it is just y equals 4x. It's y equals kx. There's nothing else with it. There's nothing being added or subtracted out here. It could technically be considered a plus 0 because it goes through the origin. So that would make it proportional. So in this case, for mine, linear and proportional is B. For the second one, it does have a constant rate of change at just an x value, so it is linear. There's no x squared or anything like that. It has a plus 9 out here. So as we've talked about on previous problems, this means that my y-intercept, my b value, is 9. If there's a b value that is not 0, then there's no way it can go through the origin. It has to go through 9, which would mean that this is non-proportional, which in this case would mean A. Next, we have a table. Now remember, to check for linearity in a table, we have to check to be sure there's a constant rate of change. So from 6 to negative 12, well, if we go down 6 to get to 0, and then we go down 12 more below 0, we went down a total of 18. And then from negative 12 to negative 48, we go down a total of 36. And from negative 48 to negative 60, we go down 12. Then from negative 1 to 2, we go up 3. From 2 to 8, we go up 6. And from 8 to 10, we go up 2. So I have negative 18 over 3, that change in y over change in x, should equal negative 36 over 6, which should equal negative 12 over 2. When I divide each of these, I get negative 6, which means this test right here proves that it is linear, which, judging by our two choices, we already gathered, but I want to ensure you can do that. Now, the proportional side of things says that y over x, not the change in, but just the plain y over x, should always give me the same value. So in this case, that would be 6 over negative 1, negative 12 over 2, negative 48 over 8, and negative 60 over 10. When I divide each of these, again, I get negative 6, which tells me that this is proportional. So this is linear and proportional. So that would be B for this case. My next table, from 2 to 8 goes up 6, from 8 to 20 goes up 12, and from 20 to 24 goes up 4. Then from negative 1 to 2 goes up 3, from 2 to 8 goes up 6, and 8 to 10 goes up 2. So when I divide here, I have 6 over 3 should equal 12 over 6, should equal 4 over 2. So that gives me 2, 2, and 2. So this one is linear. Now to check for proportionality, I'm dividing 2 over negative 1, and 8 over 2, and 20 over 8, and 24 over 10, which is not equivalent, which would mean that this is non-proportional.